Today we are talking to two scientists about synthetic elements, and it is the anniversary of the first synthetic element founded.
Lead scientist Natalie and lab assistant Catherine.
I'm Alex.
And I'm Nick.
And we're Vala News. Alright, first of all, what are synthetic elements?
Synthetic elements are elements on the periodic table of elements that are not found naturally. These chemicals are all man-made by humans who have manipulated particles to create new elements. And they're all radioactive because all of the elements we have discovered so far have an unstable amount of neutrons and protons.
And how many synthetic elements are there?
There are 24 elements.
Can you name all of them and how and when they were made?
Sure, the first synthetic elements were made in 1944, and it was called americium. Scientists working at the University of Chicago used plutonium and more neutrons in it to make americium. They are mostly used in smoke detectors. Californium was made in 1950 in University of California Radiation Laboratory in Berkeley, and was made when cerium-242 is bombarded with alpha particles. And californium is used in portable metal detectors.
Then we have curium, also made in 1944, named after Marie and Pierre Curie. And like americium, was made when plutonium is bombarded with neutrons, but in a smaller amount than americium. It is used for radioisotope thermal generators on board satellites. And in 1944, berkelium was made. Americium-244 is bombarded with alpha particles to make berkelium. Berkelium is used for chemical studies and nuclear weapons.
Californium was made in 1950 in University of California Radiation Laboratory in Berkeley, and was made when cerium-242 is bombarded with alpha particles. And californium is used in portable metal detectors. Next, in 1952, two elements were made, einsteinium and fermium. Einsteinium is made when plutonium is bombarded with neutrons and is used to make heavier elements. Fermium is produced by the bombardment of lighter actinides with neutrons. Fermium has no commercial use, but is used to expand knowledge on the periodic table.
Then in 1995, mendelevium was made. Mendelevium is created when einsteinium is bombarded with alpha particles. Then we have lawrencium, made in 1961. A group of scientists bombarded californium in a line accelerator with boron ions. We'll talk about accelerators later. Then nobelium was made in 1966 and is formed by irradiating californium-249 with carbon-12 ions in a cyclotron.
Then we have rutherfordium, made also in 1966, but in the USSR. It was made in the US in 1969. Rutherfordium is named after Ernest Rutherford. Plutonium-242 and neon ions are nuclear fused to become rutherfordium. Dubinium is the next one, made in 1968 in the USSR. Dubinium is made when californium-249 is bombarded with nitrogen. Then, in 1974, seaborgium was made when scientists bombarded californium-249 with ions of oxygen.
Then we have borium, which was made in 1981, and is made when bombarding bismuth-204 with chromium-54 nuclei. And then we have meitnerium, which was made in 1982. Scientists bombarded bismuth-209 atoms with iron-58 ions to create meitnerium. Then we have hassium, which was made in 1984. Hassium is made when lead-208 is bombarded with iron-58 ions. Hassium is used to create nuclear power energy.
Then, in 1994, scientists fused lead and nickel together to make darmstadtium. The scientists made roentgenium in 1904. They bombarded bismuth-209 with nickel-64 and an ion accelerator to produce roentgenium. Then we have copernicium, made in 1998. Copernicium is made by fusing lead and zinc.
And fluorine was made in 1999, when scientists fused calcium-48 with plutonium-244. Then livorium was made in 2000. Livorium is produced when curium is bombarded with calcium. And then in 2002, scientists created oganesion by bombarding californium-249 with calcium-48.
Then moscovium was made in 2003. Scientists took californium and bombarded it with ions of calcium, and though it is mostly used for research purposes, it is also used to make nihonium. And speaking of nihonium, that takes us to our next atom. It was made in 2004 by scientists, and americium was bombarded with ions of calcium. Lastly, in 2010, tennessine was made and was produced by calcium-48. It was fused with berkelium-249.
The uses for elements 101 through 107 and elements 109 through 118 are only used for research purposes.
Can we go back to when you were talking about accelerators? Why is that important to the synthetic element process?
Accelerators are important to the synthetic elements process because in order to create new elements, scientists rely on particle accelerators to make the new elements.
Can you tell us a bit more about the accelerators?
Of course. Accelerators charge particles like protons and electrons at really high speeds. Then the particles are smashed onto other targets or against other particles. Through studying these particles, scientists are able to understand these elements better.
Last question. Do you see any new synthetic elements in the future?
Throughout 2012 to 2016, nihonium, flerovium, moscovium, livermonium, tennessine, and organesson were added to the periodic table, but there are no signs of element 119 sadly. But hopefully, soon we will find out more about new synthetic elements.
So thank you both for coming on and talking about synthetic elements for us and our viewers.
And thanks for watching.